Hello everyone, my name is Pragya Bukche. Today I am going to explain you the feature selection method for text classification guided by Dr. A.J. Agrawal sir. First of all, we'll see the introduction to the feature selection. So, what is feature selection? In the process of text classification, we have a training set which consists of the terms from which some of the terms are useful and some are not. So, picking up the useful terms is done through the feature selection method. So basically feature selection is the process of selecting a subset of terms occurring in the training set and using only this subset as features in text classification. Feature selection serves two main purposes. First, it makes training and applying a classifier more efficient by decreasing the size of effective vocabulary. Secondly, the feature selection often increases classification accuracy by eliminating noise features. A noise feature is the one that, when added to a document representation, increases the classification error on new data. So, one of the feature selection method is X-square feature selection method, in which in statistics the X-square is applied to the test independence of two events where two events A and B are defined to be independent if P of AB equals to P of A into P of B, or equivalently P of A by B equals to P of A and P of B by A equals to P of B. In feature selection, the two events are occurrence of the term and occurrence of the class when the rank terms with respect to the following quantity. So here is the equation to find out the value of x square of d comma t comma c equals to, which is equals to summation of e of t, which has the limit from 0 to 1, and summation of e of c, which has the limit of from 0 to 1, n of t, n of e of t, e of c minus e of t minus e of c minus e of e of t e of c whole square divided by e of t e of c, where e of t and e of c are defined as if e of t equals to 1, the document contains the term t, and if e of t equals to 0, the document does not contain the term t. Similarly, if e of c equals to 1, the document is in the class, and e of c equals to 0, the document is not in the class. N is the observed frequency in D, and E is the expected frequency. For example, E11 is the expected frequency of T and C occurring together in document, assuming that the term and the class are independent. Now we will have a look on the example in which we'll consider a class poultry and the term export. The count of the number of documents with the four possible combinations of indicator values are given as follows, in which we'll consider e of t equals to e export if 1 and e of c equals to e poultry if 1, that is n11 will be is equals to 49. Similarly, the values of n10, n01 and n00 are given. So by inserting these values in the equation of E11, that is equal to n into P of t into P of c, that will be equal to n into n11 plus n10 by n into n11 plus n01 by n, so which will be equal to n into 49 plus 141 by n into 49 plus 27,652 by n, which will be equal to 6.6. Similarly, we'll compute for the values of e of et ec in the similar way, which are computed and written in the table as follows. Now we'll put these values in the equation we saw first, so which is x square equals to x square of d comma t comma c equals to summation of and so on. So by inserting above values in the equation, we'll get the value equal to 284. So we have a table of critical values and p-values as given. Here are the p-values and here are the critical values of. Now x square is the measure of how much expected counts e and observed counts n deviate from each other. A high value of x square indicates that the hypothesis of independence, which implies that expected and observed counts are similar, is incorrect. In our example, x square is equal to 284, which is greater than 10.80. Based on above table, we can reject the hypothesis that poultry and export are independent with only a 0.01 chance of being wrong. Equivalently, we say that the outcome x square is equal to 284, which is greater than 10.83, is statistically significant at the 0.01 level. If the two events are dependent, then the occurrence of the term makes the occurrence of the class more likely. So it should be helpful as a feature. This is the rationale of x square feature selection. An arithmetically simpler way of computing x square is following. X square of t, c equals to n11 plus n10 plus n01 plus n00 into n11 into n00 minus n10 into n01 whole square divided by n11 plus n01 into n11 plus n10 into n10 plus n00 into n01 plus n00. Hope you understood the feature selection method. Thank you very much.